Local inversion of control is a trick. It's a trick for inverting the control of APIs so that instead of calling something on the subject, you call it on the object. Now, I know it sounds cryptic, so let me show you some examples of how it actually works. I'll make a class and let's make a method called adding numbers. Now, let's suppose, for example, that we have a list. So I have var list equals new list of integers, for example, and then I want to add a list item, so I say something like list.add24. Now, even though this is perfectly fine code and you all do it every day, so there's no problem with it, the problem is with readability, because this is not how we actually read instructions in English. What we're saying here is we're saying something like the following. We're saying, oh, hello list, can you please add to yourself the item with the value 24? And this isn't how you do it in English. In English, we say add 24 to the list. This is how we say it. So the question is, can we implement it using C# APIs? And the answer is, of course, yes, we can. Now, in order to do this, what I'm going to do is I'm going to define a class called extension methods, and we'll make a couple of extension methods. Now, for this particular demo, I'm going to make a static function called add2, and this is going to be generic, so it's going to operate on any type t, and the idea here is the following. So what we're doing is we're making an extension method on t, so we're making an extension method that's going to work on any type, absolutely any type. That's why there is a t in here. We'll call it self, and we're going to add self to a collection. So here we can say I collection of t called collection, for example. So all we want to do, and I forgot to add the return type here, which is also going to be t. That's actually a fluent interface I'm making. All I'm doing here is I'm saying collection.add self, and then I can also return self, and this is going to be useful in just a moment. So the idea is, instead of writing it like this, you can say 24.add2 and add to the list. Now, I know that we're paying the price of an extension method call here to add something to the list. However, the added benefit here is readability, because essentially you can say, you can read it in English, you can say 24 gets added to the list. It kind of reads from left to right. In addition, of course, you can also add it to multiple lists. So if this is something you need to do in your program and you have another list, you can say 24.add2 and then specify list2, for example. This is a bit excessive and it's actually not needed, and the reason it's not needed is because we can change this parameter, and instead of having just a single collection that you're adding the element to, I can make it a params array specifying several collections, and then we can just do for each var call in calls, and this way you add the element to every single collection. So instead of saying 24.add2list.add2list2, I can say 24.add2list, comma list2, but it's still a fluent interface. We still return self at the end of it, so after we got the add2 call, we can do something else. For example, call another extension method which also operates on an integer. Okay, so this is a simple example. Now, why is this inversion of control? Well, the reason this is inversion of control is because typically it's the list which controls the operation of addition. Here we say list.add, so list is in control. But now we're inverting control, so instead of list being in control, it's actually the value that's being added which happens to be in control of the entire operation. Okay, let's take a look at another more complicated example. Let's suppose I have some function, so I have a method called process command. Let's suppose that this process command takes some opcode, and we want to check whether the opcode is an AND, an OR an XOR, and if it is one of those things, then we do something. So typically you would write, typical C# code. You say if opcode is equal to AND, or opcode is equal to or opcode is equal to XOR, then do something. Unfortunately, once again, even though this is correct code and there's nothing wrong with it, it's not very readable. And what you're basically saying is if opcode is AND, or opcode is or opcode is XOR, then do something. Whereas what you really want to say is something like if opcode is one of the following and or XOR, then do something. So we can actually get this kind of API, and there are different ways of doing it. So some of the less efficient ways is something like the following. You say if, and then you make an array. So you make an array with and, or, and XOR. You say if this array contains opcode, then please do something. Now this is better, but it's still ugly, particularly the construction of the array is ugly, so this part is particularly unpleasant. And also you want to put the opcode first. You want to say something like if opcode is one of the following, and then make a list of the elements so that you can subsequently kind of expand the elements and change them and so on. Another approach which you see quite a lot in C# actually is when people put all the opcodes together. So they say and or XOR, and then they go ahead and they split. So you simply split the string on a space and then do contains opcode. Now this is also valid. It's also reasonably fast. Of course it's slower because you have to split a string, but it's still not what we want to do. We still want to have the separate elements for and or XOR so we can expand it easily, and we want the thing to read in an English language. So let's comment this out. Now the implementation I'm going to make is going to use another extension function called isOneOf. So this extension method is going to check whether one of the values is in fact matching what you're looking for. So we'll have public static bool isOneOf t, and this is going to once again be an extension method on t, so it works on any type. And here we'll have a params t value. So these are the values we want to check against, and we simply return values dot contains self. Now the great thing about this is that now what I can do is now I can write something like if, and then I can say if opcode is one of and or XOR, then do something. And this is probably the best that we can come up with, because now what's happening is we're getting code which is readable from left to right. We're saying if opcode is one of the following and or XOR, then do something. Okay, let's do a final example, probably the more complicated example here. Let's suppose that I have a class called person, and this class is going to have a list of names. So it's going to have a bunch of names, and it's going to have, let's say, children, list person children, also a list of people. Okay, so we have this person. Let's suppose we want to have some function which is called process, and it processes a person. Now let's suppose that I want to check that the person has no names. Let's suppose no names have been defined. Now how would you do it? Now typically what you do is you say something like if person names dot count is equal to 0, which once again it's an okay chunk of code. The only problem here is that it's once again very unreadable in English terms, because you're basically saying if person's names has a count of 0. Now what is that? Count of 0? That's not great. Now of course you can do it like this. You can say if not person dot names dot any, but once again this is not very readable because of the leading not, the leading exclamation mark. Basically what you're saying here is you're saying if the condition as follows does not hold, that the person has any names, and it's just a mouthful of words, and it's once again not great. You want to say if person has any names, or if person has no names. And for this we once again turn to extension methods. This time around it's going to be more complicated, because instead of just taking the object and some objects to match against, we're going to have a function. So I'm going to have a public static bool extension method called hasNo. So person has no names, for example. So here hasNo is generic. It takes t subject, which would be our person, and it also has t, which would be in this case a string, because names is a bunch of strings. So the name is hasNo. The extension method works on the subject, so this t subject self, And instead of taking the names, what we're going to do is we're going to take a function. Now, the reason we're taking a function here is so that we can then write an accessor for this function and have it in a readable form. You'll see it in a moment. But essentially, it's a function which takes t subject and it returns an IEnumerable of t, which is the properties. So this is kind of the function for getting the properties. And here we simply, we return and we check whether the invocation of this function doesn't give us any values. So we call props, it's a function, we call it on self, and we ensure that there are no values. That's why the exclamation mark, so not any, because we have has no. Now the end result is we can write something like this. We can say if person dot has no, and then write a lambda accessor for the names, for example. Now what we end up with is a very readable chunk of code. We're saying if person has no names, then please do something. So it's kind of readable from left to right. Now let's make a similar function for has some. So I'm going to make another function. Let's go has some, where you would remove the not from this location. And now we can check that the person has some names. So has some names. Okay, now we can be even smarter about this by chaining several of these together in kind of combinatorial logic. But for this, we need a temporary type. We need a type which carries forward the information about the evaluation that we've just done, as well as the object we evaluated this on. So here what I'm going to do is I'm going to define a type called bool marker. We'll make it a struct, not a class. Bool marker of t. And here we'll have the Boolean result, so public bool result. We'll also have the object that we operate upon, which is public t self. Now, in addition, we're going to define different operations that can combine several of these markers. So I'm going to define public enum operation, and this can be something like a none. If we haven't done an operation yet, it can be an and, or it can be an or, and we can add other ones later on. So here we'll also have the internal field for this operation. Let's call it pending op, and now we can have a bunch of constructors. So we can have a constructor for initializing every single field here. So ctor f will give me a constructor which initializes everything, but we're going to make this one well, let's make it internal actually, so that it's not accessible. So we make this one internal, but then of course we make a public one. So let's generate a constructor for a result and self. And here, instead of performing the assignments, we're going to call this other constructor that we've made, and we're going to call it with a default value of none. So here result, self, and then the value of none, meaning we haven't performed any operation yet. Now, having made this, we're going to change the return types on our extension method. So instead of returning Boolean, we're going to start returning these Boolean markers. So bool marker of t subject. This is how we're going to do it, and I'm going to do the same thing for this extension method. So now we need to change the return values. Obviously, we need to return these bool markers, where the second argument is the self, and we're going to do the same thing here. New bool marker, and then the arguments. So first of all, the actual check, and then the object we invoke this upon. And now, of course, we have a chunk of broken code here, because this is no longer a Boolean, so we need to cast an implicit conversion operator, make an implicit conversion operator to turn it into a Boolean by simply getting the result. So here I'll say public static implicit operator bool, which takes a bool marker of t and simply returns its result. So we simply return marker.result. Okay, so what does this give us? Why did we just introduce a new type? Now the answer is that we can try and combine them using these operations. So for example, if I want to combine two bool markers using the AND operator, I can say something like the following. I can say public bool marker of t and this is going to be a property which returns a new bool marker, which is a copy of the current. So this dot result and this dot self. Actually, we don't need this in both of these cases, but the last argument is going to be operator and. So operation and gets added here. Okay, so you'll see why this is done in a moment, because we're going to add new extension methods which are now going to operate not on t-subject but on bool markers. So for example, what I can do is I can define the following. I can define a new has no extension method, which is going to be look like the following. So we'll have bool marker of t has no, and then this is going to be on t and u, and it takes a bool marker, so it's an extension method on bool marker of t, which is the marker. We once again take a function, so here we have a func which takes a t and returns an IEnumerable of u. So u is the type of the property, let's call it props. Now here is the interesting thing. If the marker we've got has a pending AND operation and it's false, we don't need to do anything because the condition has failed. So we say if marker dot pending operation is equal to operation and the result is false and not marker dot result, then we can simply return the current marker because it's already failed. Otherwise, we do the invocation and we return a new Boolean marker where we do the same invocation as above. So we do all of this, but we do it with a marker, obviously. So not props of marker.self.any, and then the second argument is marker.self, thereby making a new marker. Now, what does this give us, I wonder? And it gives us the ability to write the following. So here we wrote person.hasSome, and if we want to check that the person has some names but no children, we can say if person has some, p goes to p.names dot and dot has no, and then p dot children. So this way, what we've ended up with is a very fluent and very readable construct for being able to check the presence or absence of particular properties. So here we can say if person has some names and has no children, it reads from left to right as it does in English, and that is the entire goal of the local inversion of control.